We can start.
Let's humble ourselves for prayer. Heavenly Father, you're so good, you're so great. There is no one like you. We glorify your holy name and we thank you for this lesson that you've blessed us with. We pray that you give us your Holy Spirit to actually enable us to understand whatever is going to be taught. In the mighty name of Jesus Christ, I've prayed. Amen.
Amen. Thank you so much, Mark, for the word of prayer. Uh, Today, we are going to look at trigonometric equations. Yesterday, we are looking at the different identities, and I understand that some came out, some may have failed, but that is okay. We are going to look at trigonometric equations. Then, as we advance, we shall be able to look at more identities and how to prove them. But today we are going to concentrate on how do you solve? How are we going to use those identities? Whatever thing yesterday we are doing, now we are going to look at how are we going to use them to be able to solve. So that is where our lesson is going to concentrate on. So that is what we are going to look at. Now, when we talk about trigonometric equations, an equation is anything that has an equal sign. So we have looked at quite a number of equal signs at your lower level. In primary, you were looking at those kind of equations. Take an example. We are going to look at, in case I meet such a number, let me say, sorry, let me say this is the number I have come across, that sine of theta is equal to maybe 0.5. How do I solve? This is an equation because it has an equal sign. Now we have two ways to solve a trigonometric equation. We can use the graphical approach to solve it, or we can use another approach of just calculating it. So we are going to look at two approaches such that we can remind ourselves. Now the first one is going to be the graphical approach. The graphical approach. Now, in the graphical approach, how do we approach it? Now, here we are going to solve sine theta is equal to 0.5 for the values from negative 360 less than degrees, less than or equal to theta, less than or equal to 360 degrees. In other words, we want to find all those values that satisfy this equation as long as they are lying between negative 360 to 360 degrees. Now, under the graphical approach, what do you do? Under the graphical approach, you draw your table. So in our table, we are going to come up with a table. This is my table that I do have. So in your table, you are going to have two things. You are going to have your theta, whereby theta is the angle. And then you are going to have your sine of theta, which is the equation. Now, the values of theta, since they have told us to start from 360 to 360, here it is up to you to get the range you want. Like to get the domain, the values, how many degrees are you going to be jumping in between? So it is up to you to do it. So you can decide to start with any value, and then, so allow me now, for me, I will start from negative 360 degrees. Then I'm going to be jumping 90. So from 360, I jump 90. So I'll have negative 270 degrees. Then I can go on and I jump the 90. I end up with 180. Then I'm going to go on, I jump on the 90. I'll end up with 90. Then I'll have here my 0. Then I'll go on, I'll have my 90. Remember, these are negatives, negative, negative. Then this is going to be 90, 180. Then you are going to have 270. And then you are going to have 360. And all these are in degrees. These are degrees, degrees. Members, let me know through the chat whether we are still on the same page. We are looking at the graphical approach. The difference between the two values that you come up with, it is your choice. Someone may decide to use 60, another person may decide to use 45, another person may decide to use 30. So the choice is up to you, what you really want. Then after that, you are going to place in your calculator what is sine of negative 360? You place it the way it is. And remember, these are degrees. And therefore, if they are degrees, don't put your calc in radians. You just place sine of negative 360. And here, I'm getting a 0. Place as well. You go to the next one, sine of negative 270. Here, you are going to get a 1. So can we place? Someone can raise up the hand and you tell us what you are getting for the different values. Yes, someone can raise up the hand and then you take us through the different values you are getting. Okay, Genesis.
Good morning, Teacher Kaziwa.
Morning.
So for sine of negative 180, we are getting 0.
Okay.
Then sine of negative 90, it's a negative 1.
Okay.
Even that one, teacher.
Yes, continue.
Okay. That's a 0.
Okay.
Then sine of 90, it's a 1. Then sine of 180, 0. Sine of 270, it's a negative 1. Then sine of 360, it's also a 0.
A 0. Okay. Thank you so much, Genesis. Now, members, after obtaining the values, we are going to plot. Now, your angle here is theta, and we have the sine of theta. I want to bring to your attention that now we are going to plot this on a graph, and then you look at how it looks like. Now, you are going to allow me to get my graph here to bring it a bit closer. This is my graph here that we are going to plot on. So I'm going to come here. I get my ruler to plot. I want to trace out this line here. Then I'm also going to trace out another one like that. Then on my graph, this is going to be my y. On my y is where you have your sine theta. Then on your x is where you have your theta, which are the angles. Now, since we started from negative 360, I'm going to partition that this is 1, 2, 3, and this is 4. Then I'm going to have 1, 2, 3, and 4. Then this one can be my 1, and this one can be my 2. This one can be my 1, and this one can be my 2. So that means that here we shall have our 0. This is going to be negative 90, negative 180, negative 270, and then negative 360. Then I'll have here my 90. Then I'm going to have 180. I'm going to have 270 and then 360. Now looking at the graph that we have, you have noticed that on our graph, we had mainly zeros and negative 1 and positive 1. So you're going to allow me to have 1 here and to have negative 1 here. Members, let me know through the chat whether we are on the same page. We are going to start plotting. Are we on the same page, everyone? Okay. Okay, very good. So we are very good. Now we plot. When you look at our table, when we are plotting, the first value we had was negative 360 and 0. So I'm going to come here and I plot. Let me use negative 360 and 0. When you look at my plotting, it's going to be here. When I go to the next one is negative 270 and 1. Negative 270 and 1. So that point is a point and 1 is here. The next one is negative 180 and 0. The next one is negative 90. let me be yeah, negative 90 and negative 1. The next one is 0. I just need to be sure. 0 and 0. So which is a point here. The next one is 90 and 1. The next one is 180. The next one is 270. The next one is 360. Now, when you look at what we have come up with, you notice that we are coming up with a curve. So, when you come up with a curve, you have to use your free hand to draw it. So, I'm going to use my free hand to come up with that graph. So, this is how our graph is going to look like. And now this is the graph for the sine. Now, after drawing our curve, after drawing, let me first make that part better. I think okay. Now, that is our graph we have obtained for sine. And what are we solving? We are solving our graph for, which graph are we, which graph are we solving? We are solving a graph of sine of theta is equal to 0.5. Now, the graph we have obtained is sine theta. Now, sine theta is like your y value. You notice that it lies along the y, meaning that your y is like 0.5. So now, what do? You go to your axis. Are you seeing your y values? Y values are these values that run horizontally. You check out where you have 0.5. Members, when you look at our graph 0. This is 1. So 0.5 is going to be here. So 1, 2, 3, 4 is going to be here. So you draw a horizontal line. So I'm going to come up with a horizontal line. Let me maybe use red. I'm going to come up with a horizontal line. A line of that is, hope you are not seeing that. Where? I need to be very accurate. Yeah. So now that is the horizontal line. And that is for when our curve is 0.5. Now this is when sine theta is equal to 0.5. Now in order for you to be able to get the values of the angle, remember we are looking for the values of theta. Which value of theta? Which when you substitute here, you get 0.5. Now this horizontal line you have drawn, at whatever point where it meets your curve is the point you are going to read. Now, what are some of those points? One of those points that I'm going to be picking is a point here. When you look at it very well, that it is meeting the curve. It is meeting at this point here. When you look at it, it is meeting the curve at this point here. It is meeting the curve at this what? At that point. Now, all those points that I have identified, those are the points where it meets our curve. Members, are we on the same page? Now, those are the angles you are going to be reading from your graph. Those are the angles we are going to be reading. So meaning that I'm going to be reading this angle here, this angle here, this angle here, this angle there. So what are we going to do? We are going to come and start reading. Now you get your scale. When you look from here up to here, I have 90. But from here up to here, since I have 90, I will say that what is contained in a smaller box that it is 10. So I say 90 divided by 10, which is 9. So meaning that I'll have 9 for each of the smaller boxes. So when you look very well, this is 1, 2, 3, 4, approximately 4. So I will say 4 times 9, which is approximately 36. I don't know the members are seeing that. Then I'll come to the next. Then I ask myself, what is the next? The next, I'll come here. This one, I count how many boxes? These are 10, 15, 16, 17. Then I will say 17 times 9, which is around 153. Then I'll come. So this side I don't have any. I'll come this side. This angle here, this is 10, this is 15, 16, 17. Then I say 17 times the 9, which is around 153. So this side here, the angle, so this is 10, this is 20, this is 22. Then I say 22 times 9, which is 198. So the angle here is going to be negative 198. The angle here you are getting from your graph is around 36. The angle you are getting here is around 153. Then you come to this next one, that this is 10, this is 20, this is 30, this is 35, 36. Then you say 36 times 9, which is around 324. Now, these are the approximated angle, but this is negative. Now, for us to get the values of theta, these are the approximated angles. And therefore, whenever you place in your calculator sine of 36, the answer you're going to get is going to be around 0.5. Members, are we on the same page?
Yes.
Okay. Are we there? I need to get. In case you are lost, kindly raise up the hand and then I first respond. ZTE.
Good morning, teacher.
Morning.
I am asking that why did you place sine theta here up and theta here down?
Like, do you remember how to plot? Let me say y is equal to x squared.
Yes.
Now, your y value is what you plot on your axis, is what is on the vertical. Now, this value here, theta, is what is on the x-axis.
Okay.
Okay. So if you want, you could even say that sine theta is equal to 0.5, but this is your y. So you say y is sine theta. Where you substitute the values to plot is always your y.
Okay.
Okay. Samsung.
Teacher, good morning.
Morning.
Teacher,
Yes.
how did you reach the 0.5? Like, how did you find that line to be the 0.5? And even, how have you got
Now,
these angles?
are you seeing here?
Yes.
You notice that from here up here it is 1, not so?
Mm,
But how many small boxes are you seeing in between from 0 up to here?
10.
10. So what is 1 divided by 10?
Oh,
It is 0.1.
0.5.
So
0.1.
that means that each box contains 0.1.
1.
So you count how many boxes?
5.
5. So that's how we reached on that line, that line. But what you need to know that y lines are the ones
Mm,
that run horizontally.
mm.
Yeah. Is it okay?
So then the angles.
No, the angles, still you first look for the scale that from here up to here, you have
Mm,
90 degrees. But in between, you have 10 smaller boxes. So you say 90 divided by 10, which is 9. That means that each of these smaller boxes contains 9. Now, this point where the line has met your curve, you count how many boxes do you have from 0? That 1, 2, 3, 4. Then you say that since each box contains 9, then you say 4 times 9.
okay, thank you, sir.
Okay. Yes, Amara?
Teacher, I was confused on this part also. So in
Mm.
between, like you left a space of 2 centimeters and you
Yes.
divided it by 9, right?
Yes.
Then the number of boxes now where, like, let me say where 0.5 hits on the, let me say the curve, whereby it hits on the curve, right? You
Mm.
said now from the distance of where the small box is, You multiplied that number by 9 to get 5.
Aha.
Okay. But
Okay.
teacher, now like take for instance, is it okay. What if I said, what if I used one small book? What if I used like 5 small boxes? Would I have to still divide it by 90 then multiply those small boxes?
Yes. You say 90, divide by the smaller boxes in between. The answer you get is what you multiply times the boxes you have got.
Okay, thank you.
Okay. Mercy.
Good morning, sir.
Morning.
So when I put sign negative 198, I get
Hmm.
0.3.
Sign of?
Sign of negative 198,
Hmm.
I get 0.3090. Yet
Okay,
I thought
count.
we're supposed to be getting 0.5.
Okay, this is 10, this is 20, right?
Yeah,
21, 22. So when you get 22 times 9, what do you get?
22 times 9,
198. Eh?
198, yes.
So when you place in sign, what do you get?
Sign negative 198, right?
Yes.
I get 0.3090.
Now, where do you think the problem is?
Maybe because maybe we are not so accurate on the boxes here.
Yes. So that's where the problem comes in.
Mm,
So that's where the problem is. So that means that this curve, maybe I would have curved it better. So it came because of the curving. So this is why this is just an approximation method.
okay.
Mm,
Okay, sir. Thank you, sir.
okay. Then lastly, Edgar. But those who are accurate, these are, I've not said that these are the final thing, because some of you are very accurate. You may find that the answers you got were very accurate. Yes, Edgar?
Good morning, sir.
Morning.
So is it possible for us to get different values after plotting?
Yes. So someone who is accurate, I know for you here, you got 30 degrees. Someone who is very accurate, you got 30. So it depends on how
Sir,
someone has
for
carved.
me,
So
I
you
got
may not get
45
the
here.
same answers.
For me, I got 45 around there.
Yeah, it depends on how you are carving. The carving is where the magic is. How did you carve?
Yeah,
Yeah.
but can it still be marked, even
No,
if we
but
get those
now,
values?
when it comes to marking, now they consider a given range. Now, 45, you are very far away from the exact
Mm,
value.
mm.
Yes.
It's okay, sir.
Okay. But now, okay. Now, members, this same number, they could have given us when it is negative. They could have given us that solve for sine theta is equal to negative 0.5. Now, for such a case, still it is the same thing. You come down here, you draw your line. Where there is negative 0.5, are we safe? No. Okay, that is negative 0.5 is down here. I think I was replacing back the line. That's where negative 0.5 is. So what do? Still you do the same thing. You'll come, get the value here where your curve is they are meeting here. This is where the point is. I'll come, I read off this value. Here is the point where they are meeting. I read off the value. This is the point where they are meeting. I read off the value. This is the point where they are meeting. I read off the what? The value. So that is how you do it. Sometimes even they can tell you, what about, let me say, even they can tell you that when sine theta is equal to 1, so you come, you draw your line very well that this is where I have the 1. So now you check out which angle is that this is the point I read off this value here. This is the point I read off the what? The value. So in the chart, can you tell me if sine theta is equal to 1, which values are you reading from your graph? Which answers are you getting? Place them in the chat quickly.
I am following on this one.
So, tell me, which values of theta are you reading? I want you to read off from here. Place your answers in the chat. What are you getting? Very good. Negative 270 and 90. Negative 270 and 90. Now, dear members, this is how you draw it. This is how you draw it on your graph. But you are going to allow me now to show you what about if you have gone in the real world. Because in the real world, members, we can draw but as you can draw them, but we always use softwares to draw these graphs. More so when it comes to analyzing the graphs and the rest of that, we use softwares. And one of the softwares that we use is called GeoGebra. Those who have learned programming, you can as well use R programming. You can use the Python as well. So those ones can as well be used. But my software is still opening. Once it opens, I will be in position to show you how it works. But for Accuracy purposes, these softwares do much better. They bring out something very accurately that someone could have obtained if he had used. Now, this is the software we use for drawing. It's called GeoGebra. Now, those who have time, you have a laptop, you have a phone, you can download it and then you learn how to use it. Now, take an example. We have been doing y is equal to 0.5. So for this software, what we do, we say y is equal to sine of x. Now, it will draw for you the graph. So that is the graph we have obtained. So that is how it will look like. And now when you look at it for it, this is how it has scaled it up. So I can make it bigger or I can make it smaller. And when you look at our graphs, you notice that also our graph looked like this. In case I'm going to just be showing you and I'm going to just be showing you. So always I want you to take note that for your sine curve, your maximum value, the biggest value you ever get from any sine of any angle here is 1. So sine has a maximum of 1 and has a minimum of -1. So your values, whenever you place your angles here, your answer will never go above 1 and will never go below -1. So the moment you place sine of anything and you get your answer above 1, know that there is something you have not done right. So this is the sketch for a sine curve. Another curve I can show you here, it can be the cos curve. In case it is cos is going to look like that. Where? Sorry. Let me delete this. And then, so the cos curve will look like that. Now, what are you noticing? That the cos curve doesn't pass through 0. I don't know whether members have noticed that. But also cos has an upper as 1 and a lower as -1. But the only difference that cos does not pass through at 0, but it has a maximum at 0. So take note of that as well. Another curve that I want to show you is going to be the tan. In case I have y is equal to tan of x, that is how the tan curve looks like. So when you draw your tan, expect it to be like this. So these tan curves, they are like that. So members, can you draw the sketch of how a tan curve looks like in your book? Just draw a sketch how a tan curve looks like. So, everyone, I have showed you how a tan curve looks like. So you draw it in your book. I can make it smaller such that people can visualize it. That's how a tan curve looks like. That is its behavior. So first draw it. Just draw a sketch of a tan curve such that you know how a tan curve looks like. I've showed you how a cos curve looks like. I've showed you how a sine curve looks like. Okay. Members, have you finished to do your sketch? These curves, by the way, don't end. It is you to restrict them. We restrict them, but they don't end. It is continuous, even if now I scroll. You will see it goes. So that's why now we bring in the ideas of domain and a range. You restrict it. So I want it to be from here up to this point. Otherwise, that's why I gave you from negative 360 to 360 degrees. Otherwise, when you look at those cos curves, let me include the cos here. When you look at the cos curve, you'll notice it can go without ending completely. Even if I include the sine, y is equal to sine of x, you'll notice that it will also go without what? Ending. So let me hope members, I'm going to remove the tan and members see the difference between a cos and a sine curve. A sine curve is the one in blue. So a sine curve will pass through here, 0. A cos curve is just maximum at 0. So you need to know the difference between the curves. One is leading, another one is lagging. Okay, members, should we continue? Let me know whether now we are good to continue. Okay, are we good to continue? Okay. No, the curves, like the curves don't end because they are continuous. Those are continuous functions, so they don't end. And no, the values for plotting, it is you to create them at this level. They don't, they will not give them to you that you plot this, no, but they can give you the domain where to end. Okay, so I think, so members, just confirm that you are seeing a blank screen on my screen. Now, that is the first approach you can use. You can use the graphical approach when you are solving. But now we are going to look at how do you solve that same equation using the numerical approach. So we are going to write, and then we are going to start with the first one. And we are going to say that solve each of these equations for negative 360 degrees less or equal to theta less or equal to 360 degrees. And you're going to allow me that we start with the first one that we have just done, which is sine theta is equal to 0.5. Now, if I have sine theta is equal to 0.5 members, in order for me to be able to get the values of theta, I'm going to get the inverse. So I'll say that theta will be equal to sine inverse of 0.5. Now I'll come back here and say, now, what is my theta? So I place my calculator. So members, you place your calculator. Place your calculator. What is sine inverse of 0.5? Place your answer in the chat. Hey. ZT says 30. Very good. So here we are going to get 30 degrees. Now, after getting the 30 degrees, we are going to go back to our quadrants. Members, the acute angle you get is always your reference angle. So this angle here, we have the first angle you get is the acute what? Acute angle. So when you look here, sine was a positive. So the first angle you have got is what you call the reference angle or what you call the basic angle. Now, since they have told us to exhaust all the values of all the values, we are going to exhaust all the values from negative to 360 degrees. Hope that is okay, members. Now, we are going to start. The first one, we know that in the quadrants, this is all students take chemistry at O level. Now we ask ourselves, since cos you are saying that this is sine, we are going to ask our sine was positive. So meaning, like you look at the value here, this is what shows that it is positive. So meaning that our second angle is going to be within this quadrant because this is where sine is positive. So what do? We are going to come in this quadrant here, then we draw our triangle. But we say that the reference angle here is going to be the same reference angle here, as long as it is close to the x-axis. So members, also here we have our 30 degrees. But how do we get the angle? We always measure our angles from the positive x-axis. So we are going to move from the positive x-axis. So we are going to ask up to this point here. Now, this is the next angle we have. Members, you tell me in the chat, from this point to this point, you know already that here there is 30. How many degrees do we have from here up to here? Okay, how many degrees do we have from there up to there? You place them in the chat. Place the answer in the chat. Very good. Members are saying that is 150 degrees. So here, our next angle is going to be 150 degrees. Because when you place sine of 150, you'll get your 0.5. Now, members, since they have also told us that they are interested also when angles are what? Are negative. We are also going to have that angle when it is negative. I don't know whether that is still very okay to members. Are we still on the same page? Now we are going to ask ourselves. Remember, these are positive what? Positive angles. Now, to be able to get the negative angles, remember what we said. We said that for anything that is negative, which direction do we move in, members? We move. Okay, thank you. We move in the clockwise direction. Very good, very good, very good. So now, in order for us to get that angle, members, we are going to move in the clockwise direction. So we are going to come like this. Up to this point. Because we know that in this quadrant, sine is what? Is positive. So in this quadrant, when we move in this direction, that's how we get the negative angles. Now, members, you ask yourself, from here up to here, how many degrees do we have? From here up to here, these are 180, then plus the 30. So you shall have 180 plus 30. Members, which answer do you get? So members are getting 210. Not so? Yes, 210. But we have moved in the negative direction. So that is why we are going to write here negative 210 degrees. This is the negative direction. So you put the negative to show that you are moving in the negative direction. No. Okay, Mark. Remember in this quadrant, sine is what? Is negative, is positive. So we are moving in the negative direction because the domain they gave us, they told us even to give those angles that give sine as a negative. That gives the angle, when the angle is negative, you get a positive sign. Now, after getting that, we are going to move again. Remember, also sine is positive in the first quadrant. So we move again. So we move from here up to this point here, where our reference angle is. Now, your task is, how many degrees have we moved up to this point? Remember, the whole circle is 360. But here, the remaining part is that, but we are asking, how many degrees are these that we have moved? Negative, some are saying negative 360 30. So members, we are going to come here and we shall say negative 330 degrees. Why are we putting negative? Because we are moving in the anti-clockwise direction. We are moving in the clockwise what? Direction. And all angles we measure in the clockwise direction are negative. Now, members, since our angles were between negative 360 and 360, these are the angles we have. And therefore, when we are writing your values for theta, we shall write them in order. So I will start with negative 330 degrees. I go to negative 210 degrees. I go to 30 degrees. And then I go to 150 degrees. Now these are the values. Because you notice that from the graph, when we are solving it, this number using the graph, I know you noticed how our graph was moving. Our graph was like this, something like this. So you notice that when we had our line of when we had our line, we had an angle here, an angle here, an angle here, and an angle here. So these are negative values. In other words, when you place the values, when you say sine of negative 330, you are going to get a positive answer of 0.5. When you place sine of negative 210, you will get your answer 0.5. When you place sine of 30, you will get your answer 0.5. When you place sine of 150, you get your answer 0.5. So you get all those angles as long as they lie within your domain that has been given. That can result in getting 0.5. Members, are we on the same page? Are we? When you place sine of 330, members, you don't get 0.5. That's what now I want you to know. Yeah. Any questions? Any questions? Any questions at this point? Yes, Daniela.
Teacher, good morning.
Morning.
Teacher, how did you get the negative 330 degrees?
Daniela, are you seeing the direction? We moved like this. Are you seeing? Up to where your reference angle
Yes.
is. Up to where this line
Yeah.
is.
Yes.
So how many degrees are these? When you move. Are you getting? Not yet? Because these are 90, 90, 90. So since here 30 has been removed already, so what is remaining here is 60. So 90, 90, 90 plus 60. Have you understood?
No, teacher, I'm getting 300.
300? What is
Yes.
add 90 plus 90 plus 90 plus 60? You are getting? Not yet?
Teacher, I've got it. Thank you.
Okay.
Teacher, I've got
Uh-huh.
it. Thank you.
Okay, Daniela. ZTE? Okay, I failed to get ZTD.
Thanks so much. Yeah, I was inquiring how you got negative 210 once again. So
Now, 210, I'm going to move from here, like this, up to where my line is here. So this is 90, 90, and here there is 30. So 90 plus 90 plus 30 is what gives you the 210. But since we are moving in this direction, we put the negative.
thank you so much. Yeah.
Okay. Lastly, billion.
Yes. Good morning, sir.
Morning.
Master, now, pardon on the on the order of writing the theta.
Oh, like when you look here, you notice that they gave us from negative 360 to 360. Like the way you have them on the number line, like the way you have values on the number line, that this is 0, 30, 150, this is negative 2, 110, negative 330. So don't write this one before you write this. So this is like the order, like in the ascending order.
Okay, sir.
Okay. Okay, now members, let's go to the part B. Let me take you to part B. Still, we are using the same range. Now we have cos theta is equal to 0.5. Now, remember, I want you to understand. When you look here, ask yourself, according to the ratio that has been given to me, is cos positive, negative? First put for me. That's the first thing you need to understand. Is it positive, negative? Put in the chat quickly, quickly, quickly. Positive. Very good. It is positive. Now, I want you now to first know. I want to first draw this now before I start. You know that all students take Now, the next thing you need to understand, you ask yourself, in which quadrant is cos positive? That cos is positive here in the first and in the second. Number two, then you need to know your reference angles. That I'm going to, in the first quadrant, my reference angle is always here, very close to the x-axis. In the last quadrant where cos is positive, the nearest angle to my axis is here, and this is where my reference angle is going to be. That is the first thing you need always to understand. Now, after that, get your reference angle. So I'm going to come now and say theta is equal to cos inverse of 0.5. Place your calculator and tell me what you get for your cos. Yes, Wabby? Place your calc. 60. Members are getting 60. Very good. Now, this is 60 degrees. So that means that the reference angle is 60 degrees. So that means that here, the first angle you have is 60 degrees. And 60 degrees
Okay,
lies
teacher.
in the first quadrant. So that is the first thing you are going to
Excuse me,
place.
sir.
Yes, please.
I just wanted to be clear when you're choosing the quadrants to get in the reference angles. And teacher, do you only choose those that give the positive only, or it depends on the question? That if
It
the question
depends on
has
the
negative,
question.
you
Perfect. It depends on the question.
okay. So in this case, there are only two quadrants that can give us the solutions.
Exactly. All angles are going to
Okay,
be
thank
coming
you.
from there. Okay. Now, after obtaining this quadrant, the first angle is 60. So 60 is here. Remember, when you are measuring your angles, you start from here and then you measure. So 60 is there. Now, this reference angle 60 is the same angle in the here. It is the same angle here. That's what you need to know. Now, number two, this is the first angle. We are going to get the second angle. Remember, this is 60, not so? Now, to get the next angle, still we move in the clockwise direction. So we are going to move very well. Remember, we are going to first get that angle. So I'll move up to this point. Members, if you move up to this point, how many degrees do we have here? How many degrees have we moved to get the second angle that gives a positive? That is very important. Very good. Members have said it is 300. So I'm going to come here and I write my second angle as 300 degrees. Now, members, I want to tell you that we have exhausted our domain because they told us to stop at 360 degrees. So anything I go beyond is above 360. I will stop there with the positive angles. Now, after obtaining the positive angles, now I go on to get the negative what? Angles. I will draw. Now, remember, this is the 60 degrees. Now, members, if I'm to go to the negative, what does it mean? Still, I move in the clockwise direction. I start from there. So, my first line I'm going to meet is this line here. This is where I end. So, meaning that I'm going to come, since I've moved in the clockwise direction, I'm going to come and I write that is negative 60 degrees. The next one that I'm going to obtain is this side here. So I'm going to move now the second time to get the second angle. So I'll come here, up to this point here. Members, how many degrees have you moved? And give the answer in the right way. So what are we going to write as our degrees when we are moving in the negative direction? Thank you, Namara. Thank you, Danny. ZTE. Yes. Yes, Anita, Thomas. Yes, that's very good. So now our second angle is going to be negative 300 degrees. Now, after obtaining that, arrange them in order with the biggest negative, which is negative 360 degrees, negative 60 degrees, 60 degrees, and 300 degrees. And those are our answers. So what you do after, you can prove your answer. Say, when I press cos of negative 300, do I get 0.5? If it's yes, then it is okay. So you place them in the calc, you'll get 0.5. Okay, a question from Thomas.
Morning, sir.
Morning.
I would like to ask if you use the principle of 180 plus or minus or 360 plus or minus of the angle we've been given 60, you'll still get the same answers of negative 300, negative 60, and 300. Yeah.
What? You are saying you get the same answer, right?
Yeah. If you just say 180 minus 60. I mean, no, 360 minus 60, you'll get 300 positive. If you say 360, but yeah, you remember we're using the negative sign, it still will give you the same answer, but you remember the principle of negative.
Okay. How did you reach to those formulas?
It was taught at school.
Now, what we are learning now, Thomas, is how do you reach there? So how do they come about is what we are doing here.
Oh, yes, sir.
So now for you to get 360, remember here it will come to say 360 minus 60. Yes. But now like I want you to understand from the first principles.
Yes, sir.
So but personally for me, I don't teach those formulas. But I want you can discover on your own. It comes as a result of discovering that when you work out more numbers, it will start flowing naturally.
Oh, okay, sir. Thank you.
And yes, and also at a later time, you'll be learning that shortcuts can be very dangerous if you don't understand from the first principles. Because when the context changes, you may feel that things are not working out. So always start from the basics and make sure that you understand how does it come about, before you go on to the general thing. But that is very good, Thomas. I have no problem with them.
Okay, sir.
Okay. Shabela. Okay, we are going to continue. The next one is going to be it's going to be the same range domain. Sorry, I don't want it is domain. I'm going now to use part 3. Now part 3, I want us to do sine theta equals to negative 0.5. Members, now for this time around, I'm going to ask you, when you look at what the ratio that you have been given, you notice it is negative. This is the first quadrant, this is the second, the third, and the fourth. Members in the chat, I want you to identify and tell us in which quadrants are we going to have our reference angles. Uh-huh. 3 and 4. Uh-huh. Yes, 3 and 4. 3 and 4. Very good. No, Sylvia, I'm still giving you a background. We are still doing a foundation. 3 and 4. Very good. Thomas, you have a question? Or Samsung?
Excuse me, teacher.
Yes.
What I was asking that when do these quadrants change? Because in the previous question you have done for course, the first one was like you said that this one was the first quadrant, and then the where you have put 4 was the second one, and then here I'm seeing you have changed. This is the first one is this side, and then the second one is this side. So when do they change?
Are you seeing this?
Yes.
That is what determines which quadrants. you are going to place it. This ratio you have, if this is sine, it means it is negative. So you ask yourself, in which quadrants is sine negative?
Oh,
So
thank you,
that
sir.
is why people are saying 3 and 4.
Okay.
Thomas, was it a question?
No.
Okay, So what does it mean, members? I'm going to have my reference here as one of my angles, and another one will be here. Because these two quadrants, that's where my cosine is negative. So what do you do? After identifying those quadrants, members, I want to let you know, when you are getting the reference angle, there is no need to place this negative on your calc. So you are going to place that theta is equal to sine inverse of 0.5. The negative, members, just shows you the quadrant where sine is negative. So when you are getting the reference angle, you just place sine inverse of 0.5 such that we get the reference angle. Which reference angle are you getting? Very good. You are getting your reference angle as 30 degrees. Very good. So I'm going to come here, members, here, and I will place 30 degrees. Even at this point here, I will place the 30 what? Degrees. So we are going to start moving and measuring our angles. So the first measurement I'm going to take, remember we start always from 0 here. So we move up to where we have ended here. Members, in the chart, that is going to be our first angle. Remember, this is a factor, let me not call it theta. Let me call that here you are obtaining the reference what? Angle. Members, what are you getting? The first value here. Put it in the chart. What is that first value? Very good. People have said it is 150. Very good. 150? How are you getting 150? No, 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 no. It's not 150. Who is giving us 150? 210. 210. Very good. So the first one here is going to be
Misha.
210 degrees. Thank you, members. Now we go to the next one. The next one, we are going to move up to this point here. Up to this point, members. So how many degrees have we moved up to that point? Place it in the chart. Very good. It is 330. So our next one here is going to be 330 degrees. Perfect. Perfect. Now, after moving, these are the positive ones. Remember, our domain was between negative 360 to 360. Now, we go to, and we move in the clockwise direction. So you come, you start from here, then you move. So members, what is our angle there? What is the angle there? Vidal, what is the angle? Remember, the direction matters. Thank you, Abenaitwe and Mas. Very good. Members, now you are understanding. Very good. Now it's going to be negative 30 degrees. Continue now. Still move from here. Up to when you meet your line of sight here. Members, how many degrees have we moved now? Yeah. Understanding is key. Vidara said negative 150. Negative 150 mass Joshua. Benite. Yes. XX divine. Very good. So now here the next one is going to be negative 150 degrees. Now your next task is to arrange them very well. So I'm going to arrange it as negative 150 degrees, negative 30 degrees. I'm going to have 210 degrees and then 330 degrees. And members, these are your values for theta. Yes, those are your values for theta. Yes, now I'm going to entertain questions. I'm going to entertain questions. Okay, I will start with Madra, Emma. And members, always prove your answers. The moment you place these things in the calculator, you must be able to get negative 0.5. The moment you place sine of negative 30, you must be able to get negative 0.5. So yes, Emma.
Yes, morning, Peter.
Morning.
Yeah, Peter, like
using this quadrant you have done for us here, it means like all angles that are within 3 and 4, which are in anti-clockwise, all of them are negative, right?
Come again.
Okay,
Anti-clockwise, yes. Anti-clockwise
yes,
gives you positive angles. Clockwise gives you negative.
okay.
Okay. ZTE?
Excuse me, sir.
Yes.
What if the range was positive, like from 0 to 360 degrees?
Which angles here are positive?
The angles, we have 210 and 330.
Then those are the answers you'd have given.
Okay.
Okay. Alema?
And
Others?
sir, mine is just a point of inquiry. Yeah, there, they, what if the question was asking
What?
square?
Come again?
What if the question was requesting? The question was assuming sine square theta is equals to negative 0.5.
Okay. We have not reached there. We are going to reach there.
Okay, it's fine. Thank you.
Okay. Then lastly, Babi? Angel? Sorry, Angel? Okay. I'll fail to get Angel.
Good morning.
Morning.
Master, I was asking,
Hmm.
here, after
Hmm.
getting the answer, we are not supposed to put, after putting sign inverse, we can't put 150 as a negative.
Where are you getting 150? Remember, here you are solving. The question is asking you which angle, which when you place here, you get your answer as negative 0.5. What is it? Which when you place here, you get negative 0.5.
And when I place and I put in the calculator that sign inverse and I put negative 150, it gives me a math error.
No, you cannot put negative 150. Negative 150 is an angle. So you just place sign of negative 150. Then you get the answer. Sign of negative 30. These are already angles. These are not ratios.
Okay, thank you, sir.
Yeah. Okay, members, let's continue. Now I'm going to give you, yes, and always read the item to understand. Okay, solve each. It is about understanding each of these equations for 0 degrees less or equal to x less or equal to 180 degrees. Now, the first one I'm going to give you is here. Sine x is equal to 0.3. Now, that is the first one. The first thing always you have to get is your difference angle. Number two, ask yourself, in which quadrants are my angles going to come from? That is very important. So we are going to draw our quadrants. This is 1, 2, 3, and 4. Members in the chat, which quadrants are our answers coming from? Where are you going to have that drawing? Aha, 1 and 2. 1 and 2. Aha, very good. So that means that you are going to draw your thing here and a thing here. Now, number 2, we are going to get the reference. Members, can you get your reference angle? This is sine inverse of 0.3. And when you're writing our angle you get for reference, you write it to 1 decimal point. You write it to 1 decimal point. But in some books you can write to 2. Very good. 17.5. Very good. So members here are getting 17.5 degrees, which is okay. That means that at this point here, you have 17.5 degrees. At this point here, you have 17.5 degrees. Now your task is to start getting the angles. Now the first angle you're going to get, we move from here. Ta, we have moved. So what are you noticing? That you are noticing that your first X angle you have got is 17.5 degrees. Very good. Then you move again. Ta, up to here. Which angle is that, members? 162.5. Okay. So members are getting 162.5. Then I will come here and I put 162.5 degrees. And now that is the answer. That is the answer that we get. And then you stop there. Because they have told you your angles are between 0 and 180. So there is no any other angle you can obtain. Yes, Poloman.
Morning, teacher.
Morning.
It's just an inquiry. When they were teaching us, they told us that when we are stating angles, we give them to 2 decimal places. But you're saying again to 1 dp.
Now. It depends on the context there. Eh? It depends on what? On the context.
Context.
In the real
Yes.
life, when you are measuring angles, you tell us, when you are measuring angles on your protractor, how many decimal places can you obtain? If you have your protractor.
1.
1. In fact, even you may not get, but in real life, it is okay. You can write them to 2. There is not any penalty.
Okay.
There is not any penalty. It is okay. 1 or
Thank
2.
you.
Any can work.
Thank you, teacher.
All right. Okay. Is that okay, members? Zakia? Okay. Have I failed to get Zakia? Okay. Okay. Now, I'm giving you one we are trying now, everyone, to check whether we have understood the concept. You are doing this one here. You are doing cos of x is equal to 0.4. Everyone, we are trying that. And we should not leave you behind. We should not leave you behind. I want you, those sketches. In fact, yeah. So for the number of decimal places, 2 is okay, 1 is okay. There is not any penalty.
Our reference angle is 62.4.
Okay.
And then the other angle is 113.6.
1 what?
113.6.
1 13.
113.6.
Now, that is now the indicator. This is Polyman.
Yes.
Yeah, Polyman, have you drawn
Yes.
your quadrants? In which quadrants have you placed it?
The first and last.
The first one and the last. Not so?
Yes.
So which angle did you have here?
66.42.
66.42.
Yes.
Then the next one?
113.6.
113.6. How did you get this?
Teacher, I thought the angle comes from, I thought they are supposed to be alternating.
Now that is why it is important, Polyman, to first understand these quadrant things. For you, you place on your calculator, Polyman. What is cos of 113.6? Which answer do you get?
Negative 0.4.
What answer do we have here?
0.4.
So is your answer okay?
Not at all.
Yes. So that's why now you need to understand the what? The quadrants. Yes.
It's
So
246.4.
to what?
246.4.
246.4.
Yeah.
Place it in the calculator. Does it give you a positive answer?
Cos of 246.4. Still no.
Uh-huh. So hope now you are not seeing. That's why I want you to understand always from the first what? From the first principles, how things come about. Because that's what now will help you to understand the topic. So you need to remember that the first quadrant, all students take chemistry. Now, after obtaining this, your next task is that always we measure our angles in the clockwise. So how are you going to move? This one is already 6.642. Then you know that I'm going to move like this. Then you ask how many degrees have I moved? Then you say that the degrees I've moved, I'm going to say 360 minus 66.42. And you will end up with 293.58. I don't know that that is okay, Poleman.
Yes.
Uh-huh. But now you go back and reason out. They have told us that our domain is between 0 and 100 what? 80. But the
80.
next answer you're getting is above 180. So here I expect that your answer is 66.42 degrees or 66.4 degrees. Hope that is okay. Okay. Members, is that fine to everyone? You need now to look at the item and respond accordingly. They have told you your answer should be between 0 and 180. So you don't give everything you know. Give what is relevant to the item. Okay. So your answer here will be only 66.4. All right, all right, all right. And I want to clarify, when at this level, don't use the word range. Range means that, like when you draw your graph, when are you seeing these graphs? Okay, let me draw it better. Because you need to be very careful mathematically. When you use, let me say you have drawn like this. Your range, your range, members, is the y values, these values. This is what we call the range. Domain are these values, the x values. Values are these ones here. These are what we call the domain. So what has been given, this is what we call the domain. So don't use the word range. We call it the domain. Range are the y values, vertical values. Take an example. In case I'm looking for the range for the sign, that is between -1 and 1. But the domain can be -360 to 360 degrees, depending on the thing. Okay. All right. So, okay. Okay. Rose, you have a question? I want us to proceed to another. Rose, you have a question? Okay. We are going to proceed. I've failed to get Rose. So we are going to continue. Now, still we are going to maintain our what? Our domain between 0 degrees less or equal to x less or equal to 360 degrees. This is number 3. And what are we going to do today? I'm going to give you this 2 cos x minus 2 is equal to 0. That is the first one we are going to do. Now, when you look at such numbers, the first thing you have to do is first work out. Your cos must be on one side. So we shall work it out well and say this is 2 cos x minus 2 plus 2 is equal to 0 plus 2. And therefore you remain with 2 cos of x is equal to 2. So to get cos x, I'll divide by 2, divide by 2. So you will have your cos x is equal to 1. Now, like I've said, know the quadrants. So I'll come and I say now, what are going to be my quadrants? Members, which quadrants are we going to place our course? Now that's where now we need. That's the first thing. Where are you placing your course? Which quadrants? 1 and 4. Very good. So meaning that you'll come in 1 and you are going to come also where you have 4. Because that's where it is what? Positive. That is very what? Very important. Now, the next thing you are going to get is what is your reference angle? Are you getting that? What is the reference angle? So members, you place and tell me what is the reference angle? X is cos inverse of 1. Which answer do you have as your reference angle? Members are getting 0, 0. Very good. So here, it means that your reference angle is 0. What does it mean? It means that your cos is just lying along the what? The line. So when you move the first time, you are going to get 0. Now you move again. So this 0 is here. So you move again. Up to when I meet that line. So when I meet the line, how many degrees, members, do we have? How many degrees have we moved now? 360. Then I'll have 360 degrees. Yeah. So members, that is the answer you have. So Polyman, I'm seeing your answer. Polyman, you need to understand the quadrants. You go in your calculator and place, when you get cos of 180, do you get 0? That's why it is, I want you to understand it from the basics. So members, these are the two answers we shall write, and they lie between 0 and 300 what? 60 degrees. Is it fine, members? Are we happy? Are we good to continue? Okay, Gertrude says yes. Aita Wittin. Okay, very good. Anita. Okay. Okay, I think we are good to continue. Okay, yeah. Let me now give another one. And members, I want to let you, when you understand those quadrants very well, you are going to have find trigonometry very easy. Given that you have also mastered the identities that are key, life is going to be easy. Then we go to the next one. I have 5 sine of x plus 3 is equal to 0. Still, here we are using our range. I'm giving you 4, negative 180 degrees less than x less than 360 degrees. That's what we are finding. Now, the first thing you do, you solve the equation. Is that fine? You first solve the equation. So can we first solve and you tell me what you are getting? First solve that equation. Make sure sine x is on its own side. But I'm going to just pick out someone randomly. I know Mugisha. Mugisha, can you unmute? Okay, I'll fail to get I know Mugisha. Anita Elvin, can you unmute? I'm failing to get. Gertrude, can you unmute? Okay. Yes, Gertrude?
Good morning, sir.
Morning. Take us through the first step.
So 5 sine x plus
Mhm.
0 plus So I'm not very sure about the first step.
No, first make for us sine x the subject. I want you to have sine x on one side.
Okay, it will be 5 sine x. It will be sine x plus 3. It will be
Okay, we are going to start from here. Work out for me this. Find x. Gertrude, find x here.
our x will be 3 out of 2.
How did you get there? That's what I want.
2x is equals to 3.
How did you go? Don't jump step. Take me step by step. Just imagine you are teaching a P2 kid how to work out
Okay,
this.
the 3 crosses the equal sign, then it becomes a negative.
Remember, you're teaching a P2. Is that how you are going to teach the P2 guy?
2x plus 3
Mm-hmm.
minus 3 is equals to negative 3. 0 minus 3.
Mm-hmm.
Then this cancels. The 3 minus 3 cancels to be 2x
Mm-hmm.
is equals to negative 3.
Mm-hmm.
Then we divide by 2.
Mm-hmm. So, can you apply the same approach here? Let's go. Step by step.
5 sine x plus 3 minus 3
Mm-hmm.
is equals to 0 minus 3.
Mm-hmm.
Then it becomes 5 sine x
Mm-hmm.
is equals to negative 3.
Mm-hmm.
Then we divide both sides by 5.
Mm-hmm. Is it fine now?
Yes.
Okay. Which quadrants are we going to place our answer?
The first one and the second one,
Why?
because sine is positive in all and in the first quadrant and in the second quadrant.
When you look at what we have remained with, is it positive, negative? The ratio is what determines the
Negative.
quadrant.
Okay, we are going to use the third one and the fourth one.
Okay, good. We are going to use the third one and the fourth
And the
one.
fourth
Okay,
one.
thank you, Gertrude. Alison?
I just wanted to give the answer, but he has taken us through.
Okay, give us what is your reference angle?
My reference angle was 36.9 degrees.
36.
36.9.
Okay.
But since we know our sine x was a negative, so it means we are going to find our reference angle in the third quadrant and fourth quadrant.
Okay. In the first
In the
and the
third
third.
and fourth. Yes, in the
Okay.
third and so our first angle shall move from this is 0 up to this positive 30, this one, up to there. So up to there we get 216.9 degrees.
200.
216.9.
Point
And
nine.
then, yes, and then we move from 0 anti-clockwise up to that angle. So there we get 323.1. And then since our angles, again we get another one. Another one is we move anti-clockwise from 0 From 0 up to the first angle, where that angle, in the fourth quadrant, from 0 up to where that angle ends.
Like
and then
this?
we get, yes, so we get negative 36.9.
Okay.
And then we also move from 0 anti-clockwise up to this angle. Then we get 233 negative.
Are we
No,
safe?
sorry. We get negative 143.1.
Okay. Okay. Thank you, Alison. Yeah.
Oh.
Okay. Members, let me hope those are the answers you have. Polyman, is it a question? And Dollar? And Rose?
No, teacher, you corrected it. The reference angle, he had given it in positive.
In positive?
He had given his reference angle in positive.
Which is very okay, Polyman.
Sir, I thought that since the reference angle was negative, so our answers were going to lie in the what? In the third quadrant and fourth. But he used the first quadrant and the third. That's where I'm confused from.
Okay, look at the diagram we have. Are you seeing which? This is your first, right? Second, third, and fourth, right?
Yes, teacher.
Like what come again on your question now?
I thought we were using the first and the third quadrant because
Why the
it's
first?
and I'm like he used the first and the third quadrant. Yet the reference angle was a negative.
But I'm not seeing him using. Aren't you seeing these ones? I'm seeing they're empty. Rose, are you seeing? These two are empty. He has used these two down.
Oh, I get it now.
Okay.
Yes, good morning, sir.
Morning.
I'm seeing people coming out with different answers. So I don't know. I also did mine here, and answers came out. I don't know whether I can
Are these
read
the
them
answer?
for you. No,
Are your answers like this?
they are not like that.
Read for me the first one.
The first one is negative 138.2 degrees.
Now what you do, okay. Continue.
The second one is negative 41.8 degrees.
Now get that answer. Place it here. You just place it. Sign of that answer and check whether it gives you that.
Yes, it gives that because I changed that one to what? I changed it to a decimal point and it's negative 0.6.
Negative?
0.6.
And what is negative 3 divided by 5?
It's negative 0.6.
Okay. Yes, accurately. So this one, it is not okay. How did you get this?
I got that one when I'm moving anti-clockwise so that I get the so that I get the negative angles.
How did you move? What was your reference angle?
I
Because that is the
moved clockwise. I moved clockwise.
but what was your reference angle?
My reference angle was 41.8.
How did you get 41.8?
Sin I got sine inverse, and then I opened a bracket, 3 out of 5 because we leave the negative aside. Yeah, 3 out of 8, and then I got it.
So what is sine inverse of 3 out of 5?
I got 41.8.
Then there is a problem with your calc. Now, there is a problem with your calc. Now,
Okay, I'm sorry, sir. Yeah, there's a problem. It's 38. It's 36.86.
Okay.
Yes, thank you.
Okay. What was the problem? Maybe others can learn.
The problem I had was that I didn't refresh the calculator before doing it, so it brought in a different
Maybe perhaps
answer.
it was in complex mode.
Oh, okay. Okay.
Yes, thank you very much.
Okay. Okay. Yes. Dollar. Okay. Asha, is it a question? Or we are going to continue? Allow me to give another one. So, okay. We are moving on to another one. Members, we have not done any turn, but allow me to bring in some turns now. Number 3, we have 5 tan of x plus 7 is equal to 0. And what is our, and when they don't give you the range, you give as many values as you can, but you limit yourself because of time. Yeah. So we have 5 tan of x plus 7, and allow me to limit it between negative 360 degrees, less or equal to x, less than or equal to 3. Okay, let me today stop at 180 degrees, such that I test the understanding. Okay, can we now first try out this, everyone? Me is asking, teacher, do you advise this? I want to say I strongly do not advise. Yeah. I want you to just understand. Okay, Infinix, let me hope you have understood. We use 3 and 4 because that is where our sign is negative. Yeah. Is it a must to start from 0? When you are measuring your angles, we start from 0. Thank you, Nicole, for responding. Oh, yes. I think that is okay. It was negative 1/8. Okay. So we are calculating, everyone. Yes, Poleman?
Teacher, the answers, we have the reference as
Okay, take us
54.5.
through. Take us through.
Okay, we are going to take the 7 the other side, which is going to become a negative 7. Then we are going to divide both sides by the 5. So tan x is going to be negative 7 over 5. So tan inverse of negative 7 over 5 is going to be negative 54.5.
But Poleman, we say that that negative is just an indicator where your thing lies. I don't know that you're getting it. So which
That's the
angle do you
part.
get?
The reference
Mm.
is 54.5.
Mm.
So when
So
we go
in
to the
which
quadrant,
quadrants? Uh-huh.
so teacher, when we are putting in the quadrants, do we put where it's negative?
Yes, where tan is negative.
So meaning it's the second and the last.
Uh-huh. So the 54 is going to be here
Yes.
and here. So
So
what
the
are the
second angle,
values?
we have for the positive, we have 125.5.
Okay, that one, which is 180 minus the 54. Okay, it is?
125.5.
Okay.
And then the negative,
Have you
we
exhausted
shall,
them?
no,
Mm-hmm.
then we shall have, since we had the range as 180, we shall leave there. Then
Okay.
negative. So teacher, the 54.5, do we put it in negative? Because it's also a
Why?
mark.
It is, yeah, because when you move here, when you are moving in the clockwise, this is negative. So we shall
Negative.
have it.
Then
So we shall,
negative 234.5.
then,
Negative 234.5.
okay. Thank you. Yeah. Members, do you have that? We have eliminated the other one because it was going to go beyond 180. Yeah. Uh, okay.
So teacher, meaning if I get the reference angle and I have like the negative, even if I don't put the negative.
Yes. The negative just shows you where the quadrants.
Okay, thank you, sir.
Mm. So, yeah. Like I said, your reference will always be positive. Thank you, ZTE. So we don't include the 305 because it's not within the range. Okay. Why do we go different directions? Because you note that the domain that has been given, it is from negative 360 to 180. So mean that you must give both angles. Does it apply to cos? Yes, as long as it is a trigonometric function, everything we are doing now applies. Okay, Rose, is it a question? And Wabi?
Yes, sir, pardon me on how we
Yes,
are
it
getting
is.
there. This is confusing me.
Which angle?
After getting the reference angle, then getting the angles from the quadrant.
Yeah, do you hope you know how to label the quadrants, that this is all sine, tan, and cos. But you
Yes,
look
sir.
here, our ratio is negative.
Yes, teacher.
So the only quadrants where tan is negative is this quadrant and this quadrant.
Yes, teacher.
So to get positive angles, we said you move in the anti-clockwise direction. So you move like this. That is one angle. Then the second angle would have been this, but you notice that it is already above 360.
Yes.
Then to get the negative angles, we move in the clockwise. So this is the first one.
Yes.
Then the second one is here.
Yes.
Yeah.
Thank you, teacher.
Okay. Okay. Allow me to that we do one more. Oh, okay. We still have some time. Okay. I'm going to bring in a new concept a bit. Hoping that members have started now mastering a bit. So let me add on now. I have 4 plus 2 tan of 2x equaling to 0. And 4, 0 less or equal to x less or equal to 180 degrees. And this is where I want you now to pay more attention. We need to be very careful here. So what are we going to have? Here we are going to have 2 tan of 2x. This is 4 plus 2 tan x is equal to 0. And therefore we shall have 2 tan of 2x equaling to negative 4. Then we remove our 2, so we shall have tan of 2x equaling to negative 4 divided by 2. And therefore we shall have our tan 2x equals to negative of 2. Now, the first thing you are going to obtain your reference angles. So we shall come and say our 2x is going to give us tan inverse of 2. Now, members, you notice that this side we are remaining with a double angle of 2x. Now, you are going to first exhaust the tan inverse of 2. All those, you are going to first exhaust all those angles which are negative for tan. That's the first thing. You go back to your quadrants. That's where the understanding is key. Now you ask yourself, in which quadrant is tan negative? That tan is negative in the in the second and the third. So you first get what is the tan inverse of 2. Then you say tan inverse of 2, you get your reference angle as 63.43 degrees. So that's what you are going to place here, that this is going to be 64.43 degrees. This is going to be 63.43 degrees. Then you first get all the angles first. So I'm going to ask you, we are going to exhaust all angles between 0 and 180. And now 0 and 180. First you get all the angles. Here don't limit yourself at first that it is not between 0 and 180. First get all the angles. So in the chart, can you first give me the first angle you get? What is the first angle? What is the first angle? What is your first angle? 116.5. Very good. So I'm going to come here and I write 116.6. Good. Members, get the second angle. The second angle is here. Get it. Which angle do you get? What is the second angle? Witten is getting 296.6 degrees. Okay. Now, members, this is where I want you to understand. Now, after you obtaining these two angles, that's when the 2x is going to come in. Now, you are going to say that now the angles you have got 2x. One of the angles is 116.6. To get the value of x, you divide by 2, divide by 2. So your x is going to be 116.6 divided by 2. So 116.6 divided by 2 will give you your 58.3 degrees. That's the first angle. Then the second one is 2x equals to 296.6. Divide by 2, divide by 2. So you said 296.6 divided by 2. So you end up with 148.3. So here you'll have 148.3 degrees. Now these are your two values. Hope you have understood. When it is double, when the angle here is not just one angle, you have to first get all the angles, exhaust them, and that's when you can go on and divide. Don't divide automatically by 2 divide. Those things will not work, or they don't work. Hope that is okay, members. Let me answer some 2 questions. Yes, Marjorie.
Okay, so my question
Yes.
is, my question is, when we get maybe when the question is
Come
asked,
again. You're not clear.
I'm saying
Hmm.
when the question is okay, when the answers we are getting the angles are many and maybe
Hmm.
we don't exhaust all of them. Maybe
Hmm.
the question has many angles as the answer. And we don't get all of them in the range, but we get some. Are we awarded the marks completely or not?
Like, I'm not getting you clearly, but I'm hearing angles are many, something like that.
Okay, maybe for the other question where we had like more than 4 angles as the answer, and maybe for you manage to get to. Is there a
Oh,
word
you
the
are
mark?
penalized. Marjorie, you are penalized. As long as you don't exhaust all the angles.
Okay.
So you have to get all the angles. Okay. Wabi?
And teacher, my question is when you get the angles, you didn't consider the negative ones, like when you are moved that
No, no. I think you
each of
typed. I
6
didn't
to
get you.
represent.
I didn't get you.
Okay, teacher, what I'm trying to say that when you're getting the angles, the values of 2x equals, like in the quadrants here on your graph here, you didn't consider the ones, the negative ones, like -6, 3.43, and
Yeah.
the other
It
one.
came from here because they told us the angles should be positive. So there's no need why we get the negatives.
Okay, please.
Okay. Okay. Let me give another one. So another one. The rest you can place your answers in the chat. I think I can look there. I can look there and respond. Okay. Another one. Yes, most of those things that have twe, I want you always to be, very careful. Another one is here. Okay, that is the other one. So I want everyone to first form your equation. First solve up to when you reach that point and you tell me what your reference angle is. Angela, why didn't we divide by 2? The reference angle is not part of the solution. It is just to support you to get where your angle, where the quadrants you are going to use and which angles you are going to obtain. Pause check out. Ryan, what is the accumulating rule? Okay. Okay, people are getting 11.5. 11.5, okay. Elvis,
So I just want to talk about the way we got the answer.
okay.
So it is 1 minus 5 sine 2x. So the first thing we do is that we shall first take this one. Okay, the one this side. We shall take it on the other side. This side. Okay, come
Okay.
-1. Just like that. We shall divide through by 5. We shall divide through by 5. The negative 1 out of 5. We shall
Now there
divide
is,
through by,
where is this negative Elvis going, running?
oh, we shall divide through by negative 5.
Okay.
So after that, we shall get 1 out of 5. So our rate we shall have gotten will be positive. So we
Okay.
shall, after getting the angle, we shall get the angle by saying the sine inverse of 1 out of 5. So the angle will be 11.5.
Okay.
So after getting that, we shall, since the ratio was positive, we shall consider the positive, we shall consider the first and the second quadrant.
Okay.
So, when we consider, we shall put the 11.5 there, then we shall get the angles. Since they are saying, we are going to first get the positive angles.
Okay.
So the first one will be 11.5. And then we shall move from the 11.5 to this one here to, okay, we shall get 180 minus the 11.5 to get the remaining angle. So after getting the positive angles, we shall move to the negative angles, whereby we shall consider the clockwise part. Okay, we shall move from the clockwise, we shall move from 0, moving clockwise. So when we reach there, we get the angle. We get
Which
that
angle is
angle there.
that?
So let me calculate. 180 plus 11.5, we shall get negative 100, negative 191.5. So after getting that angle, we shall also get the remaining angle. Let me get it here, 360 minus. So the angle will be negative 348.5.
Okay.
It.
Okay. Thank you.
So
Now I'm going to throw more light a bit because there are angles that you have not probably exhausted that we need. I'm going to use an example of 11.54. Are you seeing that?
yes.
Now the first angle we moved was here, right?
Yes.
That is like the first revolution. Now, but still, we can move again until we come back here. So when you come back, like when you move like this, how many degrees have we moved up to here?
360.
Now we have reached the point again. So how many degrees are those now?
How many degrees?
Yes. Which angle have we formed there and again?
I'm seeing that we've exceeded. Okay, 360. We shall just, it will be, let me see. It will be 371.5.
Okay. Allow me to add it there. Is that fine? Then we come to this one here you had. Are you seeing this? Now,
Yes.
if we also move, we move again. Hope the classes are paying attention. When we move again, this was the first movement, right?
Yes.
But we can make another revolution and we come back here. How many degrees are those?
Okay, let me see. . So we've made another revolution.
Yes. How many degrees are those?
Look a little late. It is 528.5.
Okay. We are going to now to test the negative side. Is that fine? Now, the negative
Yes.
side, I'm going to have, you had here your 11.5, and this was your, sorry, it was here, I think. No, it was here. No problem. Now, we are going to move, what? Clockwise. So the first movement you made was this, right?
Yes.
Now we are going to move again. How many degrees have we moved?
Let me ask a simple question.
Uh,
We are doing this just because of the 2x.
Perfect.
Because we are doing this because of the 2x.
Perfect.
Oh, okay, I get it now. Yeah.
So which
it
angle do we
is
have?
negative 501. Is it 0.5?
Negative
551.
551.
551.5.
Good. Now we are going to move again. So we go to this angle here. The first angle we moved was here. Now we can rotate again and come back here. So how many degrees are those?
It is negative 708.5.
0.5. Good. Yeah. But now, in case it is 3, you can move again. Is that fine?
Yes.
So when you see these two, it means that you moved, like the angle is going to be rotated like twice.
Okay, sir.
That's why we have moved twice. Now,
Oh,
after that, that's now when we bring in your 2 what? X.
the 2x we divide
Yes.
through.
Now, you start dividing and tell us the values for X.
I begin dividing.
Yes. But
So
start.
divide by 2.
I want you to start, I want to arrange them in order. So start with this biggest negative.
Oh, we begin with the biggest negative. Okay. So we are getting negative 700. Wait. 708.5 divided by 2. We get negative 354.25.
25, eh?
Yes.
Okay.
Negative 300. So then we are moving to the second one, which is negative 551.5 divided by 2. We get negative 275.8. So the other one is negative 348.5 divided by 2. We get negative 174.3. So negative 191.5 divided by 2. We get negative 95.8. So then the 528.5 divided by 2, we shall have 264.
Now. Okay, allow me to put it here. Because now for the positive, you start with a small one. Understood? Where is the gentleman now? First, raise your hand again. I've lost him. Was it Dollar?
No, I can help
Okay.
him and continue.
Okay, continue.
Okay. We have 168.5 divided by 2. It gives us 84.25. Then we have 371.54 divided by 2. It gives us 185.77.
Okay. Thank you. Yes. So,
We still have the last one.
oh, okay.
Yes, we have 528 divided by 5. Divide by 2. Pause. It gives us 264.25.
Okay, thank you. Yes. Now, members, I want you always to be very careful with the domain they
Welcome, sir.
give you. You notice that the domain was ranging from X. That means that you need to learn how to move. When you see 2X, it means that the angle you are going to rotate 2 times. You see 3x, you rotate how many times? Around 3 times. That is the meaning. And you must exhaust all the angles. Now, you note that if someone had just stopped here, you may not have exhausted all the angles. So you need to keep moving. I think you did this in senior 2 when you are looking at trigonometry. So this is very important. Very, very important. So you exhaust all the angles. And you'll notice that when you pick any of these angles, let me clean. Always to prove your answer. For you pick any of the angles, I'm going to just pick one angle here. Any. I'll say 1 minus 5 sine of 2 times, let me say, I pick 5.8. The moment I put it in the calc, that thing, the way it is, 1 minus 5 sine of 2 times 5.8, you'll find your answer as 0. That's what is going to be happening. Yeah, so you need to do what? You need to yeah, you'll find your answer 0. So that's what you can do for such. So I know the angles are many. Yeah. Okay. Hope now we have, yeah. Okay. Members is the, yes, 2 revolutions, right? Uh, No, like making 2 revolutions, the angle will go beyond 360. And remember, the first one was one range, like one domain. Yeah. Rehana, that is okay. But like I've said, you need to understand why it is so. Yes, you'll get penalized, get rid, as long as you don't have all the angles. Hey, when do you know that you have exhausted the angles? As long as the angles you have obtained are within the domain. Are within the domain they have given you. That's when you know that now I have exhausted all the angles. Okay, I think I want to pick, the questions look to be many, yet I want, now as I respond to these questions, allow me to, it is time. Yeah, allow me to just display, let me pick on Zakia as I display the items you are going to try out
Good
because it is
morning.
time. Yes, good morning. Take a screenshot of these members.
So I just wanted to consult from the other number of tan that we had 4 plus 2 tan 2x.
Hmm.
And when we got the angle, that was our reflex angle, it was 63.43, sir.
Hmm.
Then you said it was just our supporting angle. We should not add it on the angles that we get.
Yeah.
But then here, when we were doing this last number, I saw they are getting 5.8. That means we divided 11.5 by 2.
Now, you need to understand why we do so. For this case, you notice that when you put the reference angle, sign here is positive, meaning that the positive is going to come here and here. Eh? I
Yes.
don't know that this is not the number. Let me go back. I don't know that it was. What was this the number? Yeah, this is the number. You notice that here, sign is positive here and here. Now, when you put your reference angle here, you notice that your reference angle was 11.54. So when you start moving clockwise in the anti-clockwise, you notice that you land on that angle. So 11.54 is part of the solution.
Oh,
That's why we take it on
okay, sir. Thank you.
A. But for the other case, after putting your reference angle, eh?
Yes.
Your reference angle maybe was here. Something, let me say it is here. When you move like this, you notice that there is no way you're going to meet your reference angle alone. Unless you are moving in the anti-clockwise, in the clockwise what? Direction.
Okay, sir. Thank you.
Okay. Auden and Lisa, Coleman and Patricia, animate one by one as members take a screenshot.
Teacher, I was passing through the back house and I got a number, but it's giving me undefined. I don't know whether.
What is giving undefined? The calculator.
No, there's a number I was doing which has 4 cos A minus 3 sec A equaling to 2.
Cos A
Yes,
minus.
minus 3 sec A equaling to 2.
Now this is the same as first. This is I think theta not A. 3 out of cos of theta is equal to. This was 2.
Yes.
So when you take, we have not reached here, but you'll do it like this. And this is a quadratic equation. We shall handle it next time.
It was giving me undefined. I don't know whether we have undefined angles.
No. Undefined angle comes when you have got a ratio above 1. Like I've told you now, like this is cos. So you cannot have the other part of the ratio going beyond 1. So that's where the problem came from. You cannot have cos above 1 or below -1.
Okay, teacher.
Okay. So take a screenshot of this. Hope members have finished.
Not yet.
Now, I
No,
want
teacher.
to bring to your attention as well that you notice that here our answers have been given in radians, in terms of pi. I've not talked about it, but you can read about it. I think I'll talk about it in the next lesson, but you can read about them. Okay, let me add you more.
About what?
Pi, radians. Also, you do some, hey, okay. I think those ones I've given you enough. Don't do these ones. Leave number 9. Leave this number as well. Also this one, leave it for now. First leave these ones. Oh, okay. I think these ones are going to disturb you. We stop here for now. Okay, so thank you so much for attending today. I think we have gone beyond our time. Tomorrow we shall not meet. I think tomorrow is
Excuse
Saturday.
me, teacher.
Yes.
I'm requesting that you share the activity in the group.
Okay, I'm going to do so.
Thank you,
Teacher,
sir.
how come I'm not in the group? Do you mind sending the link?
Okay, I don't know. If someone has the link, please share it here.